Whoa! Look at the size of that dinosaur! I'm glad that scary giant reptile is extinct.
Actually, the Tyrannosaurus rex, while it may look like a reptile, is surprisingly more closely related to ostriches and chickens than with any currently living reptiles.
Really? How were scientists able to figure that out?
They used proteins found deep in the fossil of a 68-million-year-old T-Rex, and compared it to proteins found in birds, reptiles, and other animals.
Cool. What else can we learn from fossils?
We can learn a lot. Especially about how life forms on Earth have changed over time. Okay, let's imagine that you're a time traveler, and your mission is to figure out how life on Earth has changed over time. And the tool you have at your disposal is the fossil record. First, you would have to collect fossils. This means you would have to go out into the field and look for rocks that contain the remains of ancient plants and animals. These fossils can be bones, teeth, shells, footprints, and even preserved impressions of plants and animals. Once you have collected your fossils, you would bring them back to the lab and clean them up. This way, you can get a good look at them and see what they're made of. Next, you would have to figure out how old the fossils are. You can do this by looking at the rock layers where you found the fossils. Fossils are usually found in sedimentary rocks, and these rocks are made up of layers of different materials. By studying these layers, you can figure out in what order they were formed, and therefore figure out which fossils are older than others. This process is called relative dating. Fossils in lower layers of rocks tend to be older than fossils in higher layers of rocks. Another way you can determine the age of fossils is through a process called radioactive or radiometric dating. This method uses the natural decay of certain elements in the rocks and fossils to figure out how old they are. This process is sometimes called absolute dating because it often provides a more accurate age estimate. That is because the decay is very consistent and is not affected by environmental changes like heat, temperature, and pressure. Now that you have your fossils and know their ages, you can start to analyze and interpret the data. This means you would have to look at the fossils you have collected and look for patterns. For example, you might notice that there are a lot of fossils of a certain type of animal that lived a long time ago, but no fossils of that animal found in younger rocks. This might mean that this animal went extinct. You can also compare fossils from different time periods and look for similarities and differences between them. This can give you clues about how the animals and plants evolved over time. By looking at the fossil record, you can piece together a picture of how life on Earth has changed over time. You can see how different types of plants and animals have come and gone, and how they have evolved over time. By doing this, we can infer that natural laws that operate today also operated in the past.
Thanks for teaching me about fossils.